Today we're going to start the second unit in trig, starting with periodic functions, just a quick definition. So there are many examples of periodic behavior in nature. For familiar examples, including the rising and setting of the sun and the rise and the fall of the tides. The rhythm of the human heartbeat also follows a periodic pattern, provided it's a regular heartbeat and not an irregular beat. Alright, so what you're going to find here is there are lots of definitions. So you're going to have to follow along fairly quickly, but also review this sheet so that you know what all these words mean. Okay? Alright, so the function is periodic if it has a pattern of y values that repeat at regular intervals. Okay? So one complete pattern is called a cycle. So a cycle may begin at any point on the graph, but then it completes one complete cycle and it ends at the same point, meaning same high point, same low point, same middle point, wherever it is on the graph. So for example, it could be, I'm just going to do this a little thinner, if we start at a high point here, one complete cycle of this particular graph would be that. It starts at the high, goes through the processes, and ends at the high. I could also, if I do it at a different point, I could also start here, but as long as I end up in the pattern where I started, then I've got a complete cycle. Okay, so it doesn't matter where it starts, but you have to go through the motions of one complete movement. So the horizontal length of one cycle is called the period of the function. So let's just look at, say, this one here, the purple one. So I'm starting looking at the axes here. I'm starting at 3 and I'm ending at 7. So that means the period is 4. Okay? Again, looking at the scale is key because sometimes you will not be given scales that go up by 1. They might go up by 5s or 2s or 3s. You just never know. Okay? And my green lines here, you probably figured out they're just the axes. Okay? Alright, so in any periodic function, the amplitude of the function is defined as half the difference between the maximum value of the function and the minimum value of the function. Alright, so we're going to look at this graph here. So the amplitude, it actually gives you the calculation down here, right? Let's just highlight so you guys can see amplitudes there, amplitudes there. So same definition, you've got the maximum minus the minimum value divided by 2 because it's half the difference. Okay, so basically you're looking at from high point to low point and cutting the graph in half. That's the amplitude. Alright, so the maximum value is positive 3, minimum is negative 1. So if we actually calculate this, you find that the amplitude is 2. Now, you could have done that simply by looking at maybe counting squares, looking at the scale. So if it's 1, 2, 3, 4 squares, then you know 2 squares, whatever the value of 2 squares is, either up or down, will give you the amplitude. Now, amplitude is always positive. Doesn't matter how far below the x-axis it is in terms of whether it's sitting all in the negatives or all in the positives or a little bit of both like this one, your amplitude is always negative. Or sorry, your amplitude is always positive. My apologies. Alright, so the horizontal line that is halfway between the maximum and the minimal values of a periodic curve is called the axis of the curve. Alright, so if I go back up here, and again, it says the horizontal line that's halfway between the maximum and minimum. So this kind of relies on your amplitude. Okay, so I'm going to do this one in yellow. So if we were at 3 and negative 1, so halfway is right here, right? So that would be called my axis of the curve, okay, because it's halfway. So I can look at this and say my amplitude is 2 units here, but it's also 2 units there. It can be measured from the axis of the curve to the high point. The axis of the curve to the low point will still give you your amplitude as well. So again, you have different ways of finding the amplitude. You do not need to remember this formula in order to do it. Most of the time you can look fairly quickly at the graph and realize that, hey, I'm just looking at half of the vertical height of the function, okay? So anyways, sorry, for this one, when we talk about cutting the graph in half horizontally, we talk about the axis of the curve. Now, when we talk about the axis of the curve, we are always talking about the equation of the axis of the curve. Okay, now there is a formula for this too, but since we actually just did it on the graph, you can see that the equation is y equals 1. Alright, so you have to know what a periodic function is. Okay, repeating x values. Okay, that's what's going to make your, repeating y values, that's what's going to make your periodic function. The period is the length of one complete movement, which is called your cycle. And you know the amplitude is half the distance, half the vertical distance basically of the graph. And your axis of the curve is the middle of the graph, and it's the horizontal line that runs. Well, it splits the graph in two. Now in this one, it looks like the majority of the graph is above that axis of the curve, but it makes no difference. Even though there's only just like little slivers down here, as long as it's halfway from the highest and the lowest point, that's where your axis of the curve is going to be, and you always, always, always state it as an equation. Okay, so let's look at questions on the back. Alright, it says determine whether each function is periodic. If it is, state the period, the amplitude, and the equation of the axis of the curve. Alright, so you look at this and you have to decide, is it periodic? So I'm hoping that you're seeing that it's not periodic, and it's not periodic because the y values are increasing. Okay, remember the y values must repeat. Alright, so y values are increasing, so therefore it's not periodic. Let's take a look at the next one. Alright, so when you look at this, you have to ask yourself, are the y values repeating in a regular interval? Yes, they are. Okay, so definitely it is. Okay, so when you look at this, amplitude, well, it's from high to low, right? So you look at the high, which is 4, the low is 0, and it's half the distance between high and low, so your amplitude must be 2. Period. Well, the period length depends on one cycle. So if I look at my cycle here as starting here and going from here to here to here, start at high, end at high, I'm starting at 8, ending at 16, so that means my period length must be 8. Okay, the axis of the curve. The axis of the curve, again, is you're looking at amplitude, right? So amplitude is 2, so 2 down from here, so the axis of the curve is actually right here. It has to cut the graph in 2, depending on where the high and the low points are. So the equation of that line, because the axis of the curve is always an equation, it will always be y equals, because it is a horizontal line. So you're going to say that the equation is y equals 2.